Hey everyone, I am Jeevan, and in this video I'm going to explain about my project Behavior Driven Suspicious Account Detection for E-commerce platform using machine learning. So we know that e-commerce has become an integral part of our life. It is the primary mode of online shopping worldwide. With this growth, many suspicious activities have also evolved. Traditional rule-based systems are ineffective with this evolving fraud. So the practical monitoring of every single user is also not feasible. So to address this, I have uh, developed this project. So the goal of the project is to identify the suspicious user and flag them. So what do I mean by the suspicious behavior here? So the difference between a normal user and a suspicious user can be found easily. Like a normal user can order one product at a time. For example, in 1 second, you can click maximum of one button or maximum of two products. In case of suspicious user, they can buy hundreds of products per second, try thousands of password per minute, placing 100 orders instantly, and checking prices 24 bar 7. So these are the some of the examples of what I mean by suspicious users. So it can be done by automation and scripts and something like that. So this will affect the legitimate customers of that particular e-commerce website. To address this, I have made the project. So now let us look at into the issues and challenges of this project. The first issue would be high volume of user data generated. So definitely millions of users use e-commerce platform day to day. So enormous amount of data would be generated. So handling this enormous amount of data would be a huge challenge. So dynamic and evolving fraud patterns. So as we all know, the fraud pattern would not be a fixed trend. So it would be always evolving over time. So tracking them and detecting them would be a high challenge and a huge task. Static rules would definitely fail to detect the new attack strategies. High false positive rates affecting genuine users. So it would be a huge challenge to differentiate the genuine users from the suspicious users. Even the genuine users might get flagged as suspicious users at some cases because, as we all know, we cannot predict behavior as suspicious or normal at some extent, some rare cases. So lack of labeled data for training supervision model. So the data from the e-commerce platform would not be a labeled data. So it would be a challenge to train the models with this not labeled, unlabeled data. Behavioral data contains noise and inconsistency. So the data from the e-commerce would definitely contain duplicates and redundancies. So it must be handled to reduce the noise and inconsistencies to train the data. Real-time detection requires increased complexity. So a complex logic would be required to detect the suspicious users at real time at a quicker instant. Privacy and data security concerns. So definitely while exporting the data from e-commerce websites, the data security becomes a concern. So these are all the issues and challenges involved in this project. Next, let us look at into the system requirements and tools. The hardware requirements would be a processor with i5 or higher, and the RAM would be a minimum of 8 GB, and storage a minimum of 256 GB. And the software requirements would be either a Windows or Linux or Mac OS. The programming language would be Python, and the IDE would be VS Code. And database would be a structured schema database like MySQL or PostgreSQL, and the web framework would be Flask, and the visualization tools would be Matplotlib. So apart from this, we have also certain requirements from the second requirements of the data from the e-commerce platform. Those would be the user ID to identify which user, the login time, at which time the user checks in into the website. Location, the location at which the user is accessing the from which the user is accessing the website. Action count, it would be like how many actions the user is making at a moment. Orders per cancellation, like how many orders, how many successful orders per cancellation the user is making. Failed login counts, how many time the user has tried the password and it gets failed. Session count, so the user, how long the user stays for a certain login. So because some suspicious user might log in and get the data and log out soon, the session would not last longer like a normal user would use. Password reset count, how often the user resets their password. Payment failed count, how often the payment of the user gets cancelled or gets failed. And data export count, how often the user exports their data from the website. These are all the system requirements as well as the data requirements from the website. Next up, let us look at into the architecture and flow of the project. The first step would be to import the data from the e-commerce platform into our project and perform verification and validation, so that we are converting the user behavior into a numerical feature. And we are doing this because the ML model gets crashed if the data is not present. That's why we are performing verification and validation. The validation checks if if any of the listed columns is missing, and whether if each column has a minimum of 5 records. So these are the steps done in verification and validation. The next step would be data pre-processing. In data pre-processing, it is used to handle the missing values. Like if any records is missing, it would handle it by defining as a null, undefined, zero, or the mean of the previous and the next record, or the median value, like etc. etc. So handling this. And standardization. So standardization means different features have different range of values. So to make them all as a comparable feature, we are performing standardization. So these are the things done in the data pre-processing step. And the next step would be applying the ML models. So we are using two models here, two algorithms here, isolation forest and local outlier factor. So the isolation forest would divide the data set into as many trees as possible, and it will choose a random feature for each tree. After choosing, it would choose a cutoff value of its own and divides the tree into two halves. And it will continue this process recursively. The normal value takes the longest path, and the outlier gets the shortest path and gets easily detected. So the another algorithm used here is the local outlier factor. So it basically compares how close or dense each point is to with the neighbor. Like let us take a simple example of 1, 2, 3, 50. 1, comma 2, comma 3, comma 50. The neighbors of the point 2 would be 1 and 3. So it would be highly dense, but the 50 is low dense point. So in this method, we can detect the outlier easily. So this is the outlier local outlier factor algorithm. So we are applying these two models to detect the outlier and perform. So the we use two models because the global anomaly is used, the isolation forest is used to detect the global anomaly, and the local outlier factor is used to detect the local anomaly. After applying these ML models, we would combine the model results and have a final score. So using this, we can flag a user as a suspicious or a normal user. So apart from this, we will also have a fixed rule-based calculation for each feature. Combining all these ML model results, rule-based allocation, we would have a final flag on whether the user is a normal or a suspicious user. After flagging them, we would also give an explanation on why this particular user is flagged as suspicious, on what basis, on what feature, on what model he is flagged. So this is the architecture and flow of the project. So now let us finally move to the implementation part. So it is the login page. Let us enter the username and password. Yeah. So I have already uploaded a dataset here. Uh, Based on these feature, it gives the risk score and flags us whether it is okay or suspicious, and the risk percentage is also mentioned here. You can also upload a new CSV file if you have, or you can also reanalyze the existing CSV present. Here it is analyzing. So based on these features and the rules, it is giving the risk percentage. So it is if it is very low, it's a normal user. So if it is suspicious, we have the flag on cancellation unusual. So it is reanalyzed that we have given. So on suspicious, it is giving us a cancellation unusually high. So this particular user has a high cancellation. Like out of 10 orders, he has cancelled 9 of them. So it is labeled as suspicious, and it would be reported to that e-commerce platform. You can also filter by only suspicious user. So it is based on the isolation forest or the local outlier factor model. It is a it is a flagged. So yeah, you can also search the user by his ID. And the charts on based on what the risk score is. So yeah, that's the implementation of this project.